Hi everyone, welcome to join today's session talking about Alluxio 2.3. Today's office hour, Calvin Jia and I will present you basically what we're doing for the latest release 2.3 and show you some latest development in the community, like the use cases. So hope we can give you some inspiration and see how other users are using this. So we will start shortly. So let's wait for 1 or 2 more minutes. Meanwhile, for today's Q&A, please join Alluxio Slack channel. We have the link below, which is alluxio.io/Slack. If you have problems, you can also ping me the questions. Okay, let's start. So we will divide today's presentation into 2 different parts. Calvin will start talking about the new cool features in Alluxio 2.3 and how this can affect your use experience with Alluxio. And I will follow in the end to describe a few use cases I'm working with in the community. So Calvin, why don't you just introduce yourself?
Yeah, sure. Thanks, Ben. So I'm Calvin. I'm one of the maintainers of the Alluxio project, and I've worked closely with the rest of the community as well as the Alluxio team to deliver the 2.3 release. Today, we're going to talk about some of the cool new features that are available in 2.3, and then Ben's going to talk about some of the use cases where these features will be used. All right, so the first thing I wanted to talk about was kind of the high-level idea of what we were trying to do in 2.3. Basically, seeing the feedback from the community kind of determined where we wanted to focus. And the first focus area was around the hybrid cloud use case. What I mean by hybrid cloud is generally users will have some data on on-premise data center, and they want to leverage some compute in a public cloud, for example, like Amazon or Microsoft or Google. And that poses a pretty significant challenge because they need to move the data over, they need to make sure that the APIs and security settings are fine. And we've seen like significantly new number of use cases where people have been using hybrid cloud with Alluxio in order to solve those challenges. The main kind of point here for a lot of those users was that Alluxio was pretty easy to set up, as well as it just provided a large amount of performance gain or cost savings in those use cases. So we've put a lot of effort in 2.3 in order to help address those specific use cases, as well as any issues that they've encountered. A second focus area is around Alluxio structured data services. So structured data services is our integration currently with Presto, but technically with any kind of OLAP compute framework that's working with something higher level than files. So Alluxio currently works with files, but with structured data service, you can talk to Alluxio in the terms of like tables or columns. So we've kind of released structured data services in Alluxio 2.1. And so far, we've continued to see it be popular, especially among the Presto users, because it just makes it a lot easier to set up Presto and kind of work with all of the different table metadata that people may already have. For example, they can just import their Hive metastore without having to like create a new catalog for Alluxio. And we're also seeing more users in the hybrid cloud use case also pick up structured data services to make their deployment easier. And the final focus area is more kind of an ongoing effort where we see many users successful in their deployments and kind of scale up Alluxio and hit certain scaling challenges which the system previously wasn't designed for. In this release, we mainly focused on 2 areas. One is our tiered storage management. We've seen more people try to leverage the fact that Alluxio can understand different types of media. So if you have a fast set of media, like a bunch of SSDs, as well as a bunch of hard disks all on the same machine, Alluxio can help tier that storage. And in certain use cases, when the disk sizes were too large and the read-write workloads were very heavy, there were some limitations in tiered storage management. Also, another like more kind of mission critical feature is around the Alluxio metadata. So a lot of users have kind of moved into production and really do rely on the Alluxio system to kind of always be intact. They can't just like restart the system and reformat the namespace, things like that. So the idea of being able to back up their journal was very important to them. Yeah, so I'm going to go over kind of for each of the focus areas, what specific features we developed, starting with hybrid cloud. The first feature we have in hybrid cloud is just the ability to have a one-click deploy on Amazon EMR and Dataproc. EMR and Dataproc are two kind of compute frameworks that are provided by Amazon and Google respectively. And the idea here is a lot of users are bursting compute into the cloud, and that compute resides on EMR or Dataproc. So we've built a pretty close integration with both these frameworks through a framework called Terraform. And users can actually use Terraform kind of like the various components of Terraform that we've created in order to set up their own custom environments as well. So it makes kind of deploying in the cloud a lot easier because you can just put everything in a Terraform module. Another feature that we've built for the hybrid cloud use case is validate environment. And the main takeaway here is it provides users a set of tools to connect to any remote storage and easily validate that it works. Previously, a lot of users had trouble because connecting to an on-prem store is a bit more complicated than just connecting to something like S3, which is already in kind of the cloud network. And this tool helps them troubleshoot a bunch of common issues as well as just set up the connection. The kind of details about this are included in the command line. So there's three different checks. One is to check that you can actually connect to something like HDFS, and if any of the kind of configurations are incorrect. Another check is to do like an IO test. You can think of this like a speed test. For example, like if you're trying to troubleshoot if your internet is like fast or slow. This is a similar test to troubleshoot whether or not your under file system is fast or slow. And finally, the last test is a higher level check, which is a check with the Hive Metastore integration. So one of the challenges is to make sure the settings are correct so that we can access the Hive Metastore correctly and be able to retrieve all the catalog information. So another feature that we built more for the hybrid cloud use case, but this works in all use cases, is being able to synchronize metadata concurrently. We've noticed that a key use case is users want to make sure that their data in the understorage is always accurately reflected within Alluxio. And in order to kind of support that, we've built in a lot of optimizations so that users can synchronize more often as well as larger namespaces without any real performance penalty. We did this by optimizing our algorithm to be able to work on multiple paths in the same subtree at a time. So before, if you were synchronizing kind of like, let's say, one mount point, there would be kind of one thread that's synchronizing your entire mount point. Now we can parallelize that, and there's pretty much just like a huge order of magnitude improvement because of the parallelization possible. Though no, this was only going to help if your namespace is fairly large already. But that's kind of the case where we see users using metadata synchronization pretty heavily. Okay, now I'm gonna go on to the structured data services features. So for the structured data services, we mainly focus on kind of compatibility, making sure it works with more and more kind of frameworks as well as metastores. So the first feature is around supporting Amazon Glue as an under database. So a lot of users, especially kind of cloud users, they have their metadata stored in Amazon Glue instead of just a typical Hive Metastore. So they really wanted to have a native integration with Amazon Glue. And that's what we developed in 2.3. And we're continually going to be looking for other kind of cloud native meta stores to support. For example, like Google has come out with their own metadata store as well, and we're looking into supporting that. Another feature for structured data services is just support for the ORC format in terms of transformations. So before, we only supported transformations on the Parquet format, though you could use any format you wanted from like Avro to ORC, and it would work with structured data services. You just wouldn't get the additional optimizations of being able to transform the data. And the reason why we decided to support ORC as well was because we've kind of seen a mix of ORC and Parquet among the users of structured data service, and kind of the choice there, it's not really a clean cut as to say like ORC is better or Parquet is better. It's really up to the various frameworks that people are using. And finally, I want to talk about the system scalability improvements that we've made. So I mentioned for tiered storage, we've kind of made an improvement such that in heavy like read-write workloads where users are using multiple tiers of storage, we've kind of changed the algorithm so that it becomes a lot easier to use, as well as there's no kind of change in performance based on how full the different tiers are. Before, what would happen is if one tier filled up, the performance would actually drop to the performance of the second tier or worse. Whereas now, kind of the performance should be a steady performance regardless of how much data is stored. And one kind of lower level important point here is we've changed the kind of terminology. We no longer have something called evictors. Now we have something called annotators. So previously, if you were using a custom evictor, like let's say the LRFU evictor or something like that, you'll need to look for the new annotator and update your configuration. Of course, the kind of like this new algorithm, it's a lot more performance, but there's also a few trade-offs. One trade-off is the fact that we're more of doing a best effort in terms of tiering the data, whereas previously we would guarantee that like all of your most recently used data, for example, is in the highest tier. Now the guarantee is slightly looser, where it might be that, okay, maybe only 90% of your most recently used data is in the highest tier, and there's still some in the lower tiers. But because of this like flexibility, we're able to do eviction and other operations much faster. And the other improvement we made around this, like the core system, is being able to trigger a delegated journal backup in highly available deployments. So previously, backups required the master to take the backup, which would cause the master to kind of not be able to serve like user or client requests for some short period of time, usually like a few minutes. And for users who were taking regular backups, like every day they would take a backup at a certain period of time, kind of this performance loss or like this window of performance degradation wasn't ideal for them. So what we implemented in 2.3 is the ability to ask the secondary masters to take the backup, therefore not putting the load on the primary master. So now it's really like maybe a window of a few seconds of degraded performance as opposed to several minutes. Okay, those were kind of the various features, and feel free to ask like questions on our Slack channel. We'll be answering them towards the end. And Bin's going to talk about some of the case studies where these features may be used.
Thanks, Calvin. Can you go to the next slide? Yeah, so in the last few months, we see a lot of interesting users are adopting the open source technology, and we're working closely with them to help them and onboard them to move this technology to their production fleet. So one of the big efforts we're working with is with the Presto community, that we work together to improve Presto latency at Facebook. And essentially, we help them to add a Alluxio data caching layer in Presto Facebook fleet. And we have been working on this, me and also Calvin and I were both working on this for about quite a few months. And now this is moving into production. And from the earliest observation, we see a dramatic improvement in query latency. For example, I listed here, the query latency is improved by 30% for P50 and for close to 50% by P95. Also for the I/O, because adding this new layer of caching in Presto dramatically help reduce the I/O needed to read from remote data source. So as we can see, close to 60% improved reduction in I/O for remote data source. And if you want to know more about this use case, please go to the link. By the way, this talk will be recorded, and we will put this online, available for playback shortly. Next slide, please. Another engagement we're having is with a public cloud vendor, Alibaba Cloud. What they are interested in is to use Alluxio in the Kubernetes environment. As you may know, in the Kubernetes environment, it is hard for you to get data locality, or some people call this data affinity, because it's basically data will always be outside the Kubernetes environment itself. So in this case, the workloads in their mind is machine deep learning training workloads, where they need a lot of data to feed their GPUs, and they have very, very powerful GPUs. So they need a lot of bandwidth to feed these GPUs so that their users can leverage the GPU like efficiently. Otherwise, it's very expensive to run these GPU machines in the public cloud. So one thing they found in their workloads, often the training job is bottlenecked by reading data from remote object store, in their case like OSS object store. So one way to help solve this problem is to add a caching layer, so we can preload the data or having the data read it from each other rather than always go to the backend object store. So having this, we need to use the Fuse or the POSIX interface implemented by Fuse, because TensorFlow or PyTorch, typically they don't read from HDFS interface, but read from a local file system interface. So we have a separate process called Alluxio Fuse. This can emulate a POSIX interface by running an Alluxio client inside. So Alluxio is still the same Alluxio deployment, but we can expose the data to applications in multiple different ways. One way is for Presto, for Spark, we expose data in HDFS compatible interface. For machine learning or more legacy workloads, we can also expose the same data in the Fuse, in the POSIX compatible interface. So this is the way how Alibaba Cloud is using this. And by having Alluxio inside this stack, so initially the performance is not actually satisfying. We spend a lot of time to performance tuning to try to find the right parameters and also to set the system configuration correctly. So in the end, for this, this is only the result, for the earliest result. This is still ongoing. We keep seeing more and more results. But for this early result, at least we see 40% reduction in the training time, and also this is a dramatical improvement in users' cost or the resource efficiency. So we summarized this. Alibaba team summarized this in a blog as a white paper. You can also go to our website to retrieve and read this interesting blog. It has a lot of technical details inside. Next slide, please. So the last use case I'm talking about is also quite an interesting case. Basically, this is the self-driving car company, and they're running with multiple different offices in the world. So in order to have all the data in the centralized place, they choose S3 as a data lake. This is very common for people to have multiple different offices operating on the same set of data. You want to have a centralized source of truth. The problem is it's quite, first, slow, and second, expensive for them to operate. If you are operating the office in a remote region, reading from S3, and this can download. So for for the one particular use case, they are engineers, they are data scientists that need to model, to debug certain models. And they need to, for certain debug model, to debug certain models, you have to download the input data served on S3. So every time when they receive a ticket, they need to go to S3 and download it. So this is not only slow, takes tens of seconds, tens of minutes, but also costly. And they have some calculation. Each time they do this, a single ticket, it will cost them $5. So what they do, and also you have sometimes in the same office, there are multiple different engineers, analysts, they're debugging the same issue, and they will just do this downloading multiple times. So what they do, they end up doing is to install Alluxio in each regional office as a proxy for their tooling system. So whenever they need to debug a model like this, you go to that system, and that system will leverage Alluxio to download from S3 in case there was someone already downloaded this before, which is quite often. They will not only save the time to download, but also save the cost. So we just published a blog use case on this recently. If you're interested, you can take a look. So that's all I have to share today. But this is office hour, so we try to make the office hour very informal. If you have any question, either related to the presentation today or unrelated to this, but something in the Alluxio scope, I and Calvin are happy to answer. By the way, Calvin is also running, is helping running the product team. So if you have any suggestions, feel free to use this session to give some feedback to Calvin. We will very appreciate your feedback. So first of all, any question? You can put it on Slack, or you can just ping it here in the questions dialog box. So Calvin, I have one question for you.
Yeah, sure.
So you mentioned the improvements on the tiered storage. So what is the, like you have, can you go back to the slide? Yeah, so you mentioned like this is an improvement in the read-write heavy workloads because the eviction becomes O1. Could you explain to me like why, when like without the change, why and how much effort is spent in the eviction, and why eviction even happens?
Yeah, so in the previous kind of configuration, we really try to keep a strict ordering of the eviction policy and where the data is stored. So what that means is if your data, for example, if you're using like most recently used data, then we really want to guarantee that your most recently used data is in the top tier of storage. So what this means is if your top tier is full, and someone writes more data into tiered storage, we would need to first copy some data in the first tier into the second tier. Normally, we will do this in a background process. We have something called like a high and low watermark. But the problem is in very read-write heavy workloads where like the amount of writes to tiered storage is higher than kind of what the background process can sustain. The system will basically start waiting for data to be evicted from the highest tier and moved into the second tier before writing the new data. That greatly decreases your write throughput, and in a lot of cases your caching throughput, because caching is kind of a write as well. So in this new version of tiered storage, we decided that kind of in the critical path of writing data, there's no data transfer that happens at all. So that's what we mean by eviction becomes O of 1. We just kind of literally evict by like deleting the data. And that operation we found is pretty much always fast. So the difference can be on like from like, you know, milliseconds to delete something to kind of tens of seconds to copy some data over from one tier to the next. And this would be especially bad in cases where users are using like rotating hard disks and things like that, where really writing the data can be very slow.
I see. So I know, like for example, in the previous versions, there is some limitation that you can only write a file with the default policy. You can only write a file smaller or like no larger than the first tier. Is it still the same case here?
Yeah, so the limitation is somewhat alleviated in this new framework, in the sense that if you're writing data that's larger than, let's say, your top tier, which is memory, then we'll actually start writing some of the blocks into a lower tier if you have one. So previously, if you're writing like a 10 gigabyte file and you only have 8 gigabytes in memory, you just try to write, and then you'll fail after writing 8 gigabytes because there's no more space. Now what will happen is you'll write 8 gigabytes to memory, and then you'll write the other 2 gigabytes to the lower level storage like SSD.
Sounds good. And also another question, like can you go back to the slide talking about the synchronization, the metadata synchronization? Like, do you, like, for example, without this change, what's the implication and why we need to synchronizing metadata from Alluxio and between Alluxio and the UFS?
That's it's a good question. So in an ideal case, you don't need to synchronize data because all of your data accesses are going through Alluxio. So Alluxio kind of already by default knows what's the latest and most up-to-date information. But in a lot of cases, especially like in hybrid, people are just using Alluxio as a view on top of their on-prem storage. And in their on-prem storage, they have a bunch of other like ETL or like ingestion frameworks going on that are directly writing data to the on-prem storage. So what can happen is Alluxio sees a file, let's call it like file A, and it loads the metadata for that. But then later on, some ingestion job updates file A to be like file A prime, because let's say they recalculated that day's worth of data or something like that. So now Alluxio thinks file A is still file A, whereas the true data now is file A prime. So any calculations done in the Alluxio space will be using the old data as opposed to the most up-to-date data. And the idea behind metadata synchronization is that we would actively try to synchronize the data between Alluxio and the on-prem storage so that we will always see the latest data, in this case, file A prime. But the problem there is, in order to synchronize data, we need to make requests to the underlying storage or ask the underlying storage to give us updates, like for example, through iNotify for HDFS, as to like which files have changed. And previously we're handling these updates as well as checking these files in a single threaded manner. So if you had, for example, a subtree with several million files, it can take a pretty substantial time to go through those 1 million files and determine which ones need to be updated. But in the latest version in 2.3, we've tried to parallelize that operation so that even scanning like millions of files is kind of in a trivial amount of time, so that users can expect a much faster like response in terms of getting the most up-to-date versions of their data.
So how large is the speed up in your mind in the maybe extreme case, a 1 million file you mentioned?
Oh, probably like, I would say like 20, like 10x to like 20x, because basically we're going from like 1 thread to like 30 threads or something like that. And it's just like a linear increase.
Wow, that's a lot improvement. Thanks for letting us know. Yeah, I don't have more questions. In case there are someone from audience having any questions, feel free to ask us. We will be hanging here for a few more minutes. Yeah, as I mentioned, today's video is recorded and it will be available online shortly. In case anyone wants to just watch it again, it should be available very soon. Thank you for joining today's session. And thank you, Calvin, preparing the slides and introducing all the interesting features to us. I'm sure like in case in the future anyone has any question, feel free to go to Slack channel and reach out to us. I'm always curating the Slack channel. And yeah, we will see you next time in the next office hour. Thank you.